What makes subglacial lakes fill and drain? Imagine a hidden world beneath miles of ice, where lakes come and go without anyone seeing them. These are subglacial lakes, and they play a big role in how ice sheets move and change. So, what makes these lakes fill up with water and then drain away? Let's find out. The water in these lakes starts from melting at the bottom of the ice sheet. This melting happens in two main ways. First, heat from inside the earth, called geothermal heat, slowly warms the bedrock below the ice. Second, as the huge ice sheet slides over rough ground, friction generates heat. This friction can melt ice at the base, especially where the bedrock is uneven or has sharp ridges. The meltwater then collects in natural dips and valleys carved into the bedrock, forming lakes that can be tens of kilometers wide and several kilometers deep. These lakes fill up mainly through ongoing basal melting and sometimes through water transfer from other nearby lakes or underground drainage systems. The ice sheet is not smooth. It has many bumps and depressions. When water gathers in these low spots, it causes the ice above to lift slightly, creating a bulge that satellites can detect. The filling process can take months or even years, depending on the season and how much heat is available. Unlike Greenland, where surface melting adds to water levels, in Antarctica most of the water comes from melting at the ice base. Now, how do these lakes drain? When enough water accumulates, the pressure inside the lake can become very high, sometimes exceeding the weight of the overlying ice. This is called superflotation. When this happens, the water pushes open channels or conduits at the ice bed interface. These channels allow the water to flow rapidly out of the lake, acting like a lubricant that helps the ice slide faster over the bedrock. The water flow can be uneven, moving downhill through a network of channels. Once the drainage begins, it can happen quickly, sometimes over just weeks or months. Satellites can spot this as the ice surface sinks after the water leaves. These lakes are not isolated. They connect with each other through underground channels, forming a network of lakes and rivers beneath the ice. Recent studies have found many clusters of lakes and interconnected systems, meaning that when one lake drains, it can trigger others to fill or drain as well. Over time, these cycles of filling and draining happen repeatedly, especially in active lakes that see regular changes. When a lake drains, the extra water reduces friction between the ice and the bedrock, which can cause the ice to speed up and flow more quickly toward the ocean. This process can influence how fast ice sheets lose mass and contribute to sea level rise. The location of these lakes often coincides with the start zones of fast-moving ice streams, where the ice is already sliding more easily. The rough terrain and the energy released from sliding help create the conditions for these lakes to form. With advanced satellite technology, scientists can now monitor tiny changes in ice elevation, revealing when lakes fill or drain. Some of the biggest lakes, like Lake Vostok, hold thousands of cubic kilometers of water beneath the ice, showing just how massive these hidden water systems are. In short, subglacial lakes fill when heat melts ice at the bottom, and they drain when water pressure forces channels open, allowing water to escape. This cycle influences ice movement and helps scientists understand how polar regions respond to climate change.